and welcome to the Science Oxford Livestream 2024. It's so lovely to have you here. My name is Sian.
And my name is Daniel, and we are so glad you could join us today to take a look at the science of invisibility.
That's right, we're going to use some of our scientific equipment to help us explore what invisibility means and how something being invisible might actually help us.
Yes, but it's not just the two of us here bringing you the show today. We've also got Bex, who is assisting us by helping to set up our experiments and clear some things away. And we've got Ian and Roger working behind the scenes, managing the cameras and bringing your comments from the chat to the stream as well. So thank you to them for all their help bringing this live stream to you.
And thank you for joining us. It's great to know that you're here with us, watching along, and we can see some of the schools that have joined us as well. So welcome to Queensway and to Windale Primary, Barton Park, Banbury Harriers. It's lovely to have you with us.
Now, at the beginning of the show, if we didn't say hello to you just then, don't forget you can use the live chat. So please, teachers or adults, use the live chat to share the comments and questions from your pupils with us, and we'll bring some of those up to share with everybody else, just like that first question we had at the start. So let's have a look at that question again now. If you had the power of invisibility, what would be some good things about that, some bad things, and what would be some interesting things? So let's see if we have some ideas to share. What do you think could be some good ideas about being invisible, Sean?
Oh, I think if I was invisible, I could sit at my in my classroom, maybe if I was at school, and I could put my hand up and the teacher wouldn't be able to see me. I'm not sure that would be a good thing though. I'm not sure.
I think a good thing about being invisible is I could maybe go out into our woodland area or by the ponds here, and I'd be able to get really close to some of the animals without scaring them away because they wouldn't see me coming.
That's really good. I wonder something that interesting, maybe if we were, I don't know, if maybe everything was invisible, what would happen then?
If everything was invisible, that is a very interesting question. Maybe we'll have some time to think about that later. Thank you very much. So, all of these kind of things about thinking about what it would be like to be invisible has got me thinking actually what it means to be invisible in the first place. So Sean, how would you explain what it means to be invisible?
So we've done some thinking about this, and I think something is invisible if you are looking at it and you can't see it.
So like the air all around us, for example. I mean, I know it's there, I'm breathing it, but I can't see it. So is the air invisible? Yeah,
absolutely. So the air is made up of gases, and some of those gases might be oxygen or carbon dioxide or nitrogen. I just want you to do something though while you're sat in your rooms. Daniel, you can do this too. Hold your hand up to your mouth and blow on it. Can you feel it?
Yes, I can feel the air when I blow on my hand, yeah.
Fantastic. Can you see it?
No, I can't see the air.
No, so the air is invisible. And the reason why air is invisible, it's a gas. And some gases are invisible because the bits that make up the gas are so tiny and they're so spread apart that actually we can't even see them.
That's amazing. Now, I know that when we're breathing from the air all around us, it's the oxygen that we need to breathe. So even though it's invisible, I know it's there because I'm breathing it. But isn't oxygen also used in fires? Is it part of making a fire? So can it be dangerous too?
Yeah, so oxygen is one of the three things that we need to make fire. It's part of our thing called a fire triangle. We have oxygen, heat, and fuel. Now, I've got these candles just here, so you'll be able to see them on your screen in a moment. There we go. These candles are burning. They are on fire, which means that there must be oxygen in the air around them. Now, I wonder, we're going to make a gas and see what happens when I pour that gas over the top of these candles. The gas that we're going to make needs vinegar, which we've got in the bottom of our bottle here, and it needs some bicarbonate soda. Now, I've added bicarbonate soda to your balloon already, Daniel.
Thank you.
What we'll do, we're going to add bicarbonate soda to mine, and we'll see what happens and see if we can make some.
Oh, I wonder what's going to happen when I do this. So I'm going to tip the bicarbonate in.
Are you ready?
Here we go. Oh, whoa.
Hold on to it.
Oh my goodness. It's really fizzing up there, Sean.
It is. There's loads of bubbles being made.
And what's inside the bubbles then?
So if bubbles are being made in a reaction, that means that gas is being produced.
And so that gas must be filling up my balloon. You can see it's inflating here. It's filling up with that gas inside it. So, and what was the gas called again?
So the gas that's being made here is one called carbon dioxide, also known as CO2.
Wow. So this balloon is now full of CO2.
Absolutely.
And because you and I had the same vinegar and the same bicarbonate of soda, I guess in all of your bubbles, that bottle is filled with CO2 as well.
It is filled with CO2. Now, we're going to let that come down a moment, and I want you just to have a think while my gas is coming down a little bit inside my bottle. What do you think might happen if I pour carbon dioxide over the top of my candles just here? Let's have a look. Let's see. So I'm going to pour this carbon dioxide over the top. Watch really carefully. Did you see that, Daniel?
Wow. Yes, candles seem to just go out. But why did they just go out?
They did go out. So it's something really important with carbon dioxide. There are two really important things to remember when we're talking about carbon dioxide and fire. The first thing to remember is that it is not oxygen. Okay, carbon dioxide is not oxygen. So if we have carbon dioxide, that means the fire can't happen. And the second really important thing to remember about carbon dioxide is that it is heavier.
I'm having a little
oxygen.
trouble tying this balloon off, so I'm going to swap it for one I had earlier. Thank you very much. There we go. So it's heavier, did you say? So
it's heavier than oxygen.
It seems to just sink.
It does. And so what happened when I poured the carbon dioxide over the top of my candles, it pushed the oxygen out of the way and extinguished the fire or put the fire out. And carbon dioxide is a gas that we can use in some fire extinguishers for that reason.
Fantastic. That's really clever. So we had an invisible gas, CO2, in our experiment there. And we know there's invisible gases in the air all around us as well, like the oxygen that we breathe, like you said. But can you think of any other invisible things? We're going to give you a couple of minutes to talk with the people around you. And adults, it would be great if you could share the comments from your children there and the answers in the live chat so we can talk about them after this little break. So what invisible things can you think of? Hello and welcome back. Thank you very much for having those discussions in your group. So hopefully you've got some answers to the question we asked you. What other invisible things can you think of? Let's have a look at some of those answers now. So somebody here has shared wind as an answer. Yeah, absolutely right. So wind is a little bit like when I was breathing on my hand and I could feel the air moving past my fingers, but I couldn't see it. And wind is the same kind of thing as that, isn't it? You're absolutely right.
Yeah, fantastic. Any other answers that we've got coming in? We've got the sky. I think that's quite similar, isn't it? But sometimes we can look up at the sky and see completely through it.
Interesting. Yeah, I can see the stars all the way out in space. So I must be looking straight through the sky at night to see the stars. That's a really good one. Someone has shared end of the rainbow as well. That's a lovely idea. So when a rainbow is in the sky, I can see the colorful bits up high. I can't see the ends of the rainbow. Amazing.
Interesting. Someone else said, Brookside School, sorry, hello, have said germs. That's really interesting because germs are there. We know they're there, don't we? But we can't see them even when we're looking at them.
Well, that reminds me of what you said about the air. You said it was made up of things that are so tiny that we can't see them. And germs are really tiny, but we do know they're there. So,
absolutely, absolutely. And Gagglebrook have said kindness. Do you know, that's really interesting because that's something that we can't see, but we can feel.
And Brookside have said love, which is a similar thing. It's something we can feel, but we can't necessarily see it. And Hannah Weeks has said atoms as well. Again, things that are so tiny that we can't see them.
Yeah,
wonderful. Those are some really interesting. Oh, one last one here.
Spoken words. Thank you, Brookside. So I guess that's kind of sound, isn't it? You can't see the words that are coming out of my mouth, but you can hear them. You can detect them with your ears.
Absolutely right. Fantastic. Thank you very much for sharing all of those really interesting answers with us there. Now, I just want to go back to our description or our definition of what it means to be invisible again. Sean, what did you say it was?
So I said that something is invisible if you can't see it, even when you're looking at it. But for example, if I'm looking at some of these things we've got at the back here, these big tubes with coloured water in, I can see them, they're visible.
Yes, right.
But why?
So it's all to do with light. And I've got a demonstration that I'm going to show you down here. We're going to turn off the big lights in the room so that you can see it a little bit clearer. So I have got a laser here, and you won't be able to see it at the minute because it's quite dark, but if I turn it on, you will hopefully see a little red dot on your screen. And Sean's got a green one here for us as well. Now, at the minute, I'm pointing the laser at the board, so in that direction, not at anyone's eyes, which is a really important safety feature. But if I were to do this, hopefully we'll see the beam of light traveling through the air. Right now, we can't see it because it's not traveling the right direction. But if I do this, can you see the beam of light as it travels through the air?
That's amazing, Daniel. I can see a straight line all the way from the laser pointer to the board on the back.
Fantastic. That's right. That's because light travels in straight lines. And when something gets in the way of the light, like this powder that I'm pouring over it right now, the light will hit it and bounce off and travel into our eyes. And that's how we see things. When light bounces off objects into our eyes, we see them. So right now I'm making these beams of light visible by putting something in the way of it. But when there's nothing there for it to bounce off, if it's not shining in the right direction, we can't see it again. Okay.
Fab, should we turn the lights back on for a moment?
Yeah, let's have a look at what we've just done there. So we've made a bit of a mess by showing you that line of light there. But
so I think we'll probably take a minute just to tidy up this mess.
Yes.
And while we're doing that, we're going to ask you another question. So if you're able to, do write your comments in the chat and we can talk about them with you. That would be great. So the question we're going to ask you, we're going to put 4 pictures up on the board. I want you to see if you can find what is invisible in those pictures. And then I want you to think about why that invisibility might be useful. So we'll see you in a moment. Welcome back. Hopefully you had some really interesting discussions in your rooms. Let's have a look at some of those pictures, and let's look at number 1 first, shall we? Let's look at picture number 1. So Brookside, you said maybe it's a butterfly. Yeah, good, interesting. Let's see if anyone else. Oh, Headington Prep has said it's a moth. Now I can see, well, it all looks really the same.
It looks like a pattern, like a wooden pattern. I can't see anything on there at all. It just looks like a piece of wood to me.
Should we see? Oh, it is a moth.
Okay.
Good. Should we see where that is on our picture? There
Oh,
it is.
okay. I can just about make out the outline of the wings there. It's really, really well blended into that background though, isn't it? And lots of people are clearly seeing this moth as well. So well done for everyone who's sharing that there. Thank you. What about number 2? So in this picture, I was thinking, well, the invisible thing in here must be the water because I can see straight through it. Is that?
I mean, that's really interesting in itself, isn't it? Maybe it's just a rock though. That this kind of bumpy bit at the bottom.
A lot of people here are sharing. They think it is an octopus. I can't see an octopus in there at all.
Oh, hang on. If it is an octopus, I think I can maybe see some tentacles.
It is an octopus. Okay. Where is it again?
There it is. Look at that.
Oh, so those white bits down the line, that's like a line of suckers of its tentacle clinging to the rock there. That's really clever.
It's really well hidden, isn't it? Fantastic. Okay, let's have a look at picture number 3.
Oh, and Brookside said it was camouflaged in a rock. That's really interesting.
I mean, that's a good word.
So number 3.
Let's have a look. What do you guys think number 3 is? Oh, lovely. Thank you very much. We've got owl. Someone thinks it's maybe an owl. And Brookside agree. They think it's an owl as well. I mean, I can see that it looks like a tree. I think I can see that.
I thought it was an owl. I think it's a sleeping owl. I think its eyes are closed. And that's what really took me a long time to see it. Because I think of owls as their big wide eyes open. But it is an owl. That's good. We're getting it right.
Should we see where the owl is? There it is. Is that where you thought it was?
That is exactly where I thought it was, hiding in that nook in that tree. Really, really well blended in, really well camouflaged. Fantastic. Okay, and then there's one more. I don't know what this one is at all.
Brookside think it's a camera, maybe. I can kind of see that. Oh, and Headington Prep, sorry, have said a human. Oh, I can definitely see kind of the outline of a human or a person hiding. Thank you very much.
Someone hiding. Okay. So that maybe that shiny thing in the middle is maybe is a camera. Let's have a look. What do we think? Oh, it says photographer. So yeah, that's a person with a camera.
Yeah,
amazing.
It is. Well done if you said that. And there it is. Look. So that lens, that kind of big black circle in the middle might be the lens of the camera.
Fantastic. So all of these invisible things were hiding in the pictures, but why do we think being invisible would help them?
That's interesting. It's interesting. So Hannah Weeks has said maybe that the predators can't see them.
Ooh, so a predator is an animal that's maybe trying to hunt it, and they want to try and hide from that so they can be unseen.
Yeah, good. So lots of ideas around the invisibility. Visibility helps them hide from predators. Maybe also helps them hide from prey.
Interesting. So they can sneak up on their own prey without being seen as well.
Yeah.
That's a really good idea. And actually, I have got an example of an animal that is very well camouflaged here. I'm going to bring it onto the close-up camera. So you can see here that this little leaf insect is doing a little wiggle like a leaf blowing in the wind to try and camouflage itself with the leaves that it's having a nice little munch on, so that if there were any predators like a bird flying past, it would seem to blend in with its surroundings and it wouldn't get seen and eaten. I think that's really clever. So hopefully you could see there that really clever camouflage of the leaf insect hiding amongst the leaves there. I'm going to pop that back in here and take it out of the way. But camouflage is a really interesting thing, isn't it, Sian?
It is really interesting. Now, we can... it's a bit hard, actually, when we're thinking about camouflage, for humans to camouflage.
Yeah, so humans can't camouflage in the same way as the leaf insect or the octopus that we saw in the picture there. And we can hide a little bit, but what we can do is use our knowledge of science and light to create optical illusions.
We can, yeah. So I've got something here that's going to help me show you a little optical illusion using light and materials. I've got a funnel that is made out of glass. Now we can see through that glass because the light is able to travel into it and through it. And when it does that, it changes direction ever so slightly, which means we can see it. Now I've got a pot of oil here that you'll be able to see on your screens. I'm going to pop my funnel inside the oil and I want you to watch carefully to see what happens.
Wow, it's disappeared entirely. It was like when it went into the oil, I couldn't see it at all. It's invisible.
No, so it's very interesting. I mean, just take it out and I'll show you one more time for those of you that didn't quite get to see it. So because the because the funnel is made out of glass, the light travels to it and changes direction ever so slightly. When I put it inside the oil, and this time I'm going to show you, I'm going to put my thumb over this hole here at the top of the funnel. And what's that going to do is trap the air inside the funnel.
Oh, I can see it this time.
Because you probably saw some of the air come out there on the side. Because the air is inside, the light is bouncing off that air and it means we're able to see it. Now I'm going to take my thumb off the top of this. I'm going to maybe count down after 3, ready? And you can watch. We'll go 1, 2, 3. Go.
So now, I can see now the oil is filling in from the bottom and pushing the air up through the top.
Yeah, so the air is coming out of the hole at the top my thumb was covering. And the oil is filling up the funnel from underneath. And because the oil and the glass funnel change the speed of light at the same amount, it means that we can't see it anymore.
That's a really clever optical illusion to make something visible look invisible. That's really cool. I like that a lot. But I wonder if there's anything we can do to make something that is invisible visible. So we've actually got a piece of equipment here called an infrared camera, which can detect infrared light. Now, the light that we use to see is called visible light, and infrared light is something that our eyes cannot see, but we can feel it, we can detect it as heat. And the camera we've got, the infrared camera, can pick up that infrared light and it can create an image using its infrared light based on the temperature of things. So Sian, we're looking now at what the infrared camera can see, but Sian, what do you think are the hot colors there and what do you think are the cold colors?
So, well, I can feel my face and it feels really warm because I've been talking about, actually, if I look on the camera, my hands look really blue and I can feel them and they feel really cold. So maybe red or white is hot or warm, and maybe blue is actually really cold.
You're absolutely right. And so this camera can show us things that we can't normally see with our eyes. I think it'd be quite hard to hide from this camera.
Absolutely. Now, I do have a way that I think I can hide from this camera.
So?
Yeah. So I've got a thin piece of plastic just here. And this bit of plastic is a word that we use to describe something where you can't see through it. We use a word called opaque. Now, we can't see through this plastic because the light can't travel through it. Okay?
That's right. If something's opaque, light doesn't travel through it.
Absolutely. And if I hold this up, you can't see me. So I think that maybe if I hold this up in front of the infrared camera, you also won't be able to see me. Should we have a go?
I think so.
Okay,
let's have a look. Now that is really interesting. So if we look on the regular camera where we can see ourselves really clearly, yes, it's blocking the visible light. So it's not letting the light we use to see through it, but the infrared camera can still see you through the plastic sheet. So the infrared light must still be able to pass through this material.
Oh. Okay, so I'm not really invisible to the infrared camera.
Not when you're hiding behind that. But I've got another material. Let's try this in front of the infrared camera. I've got here a sheet of glass. Now, if I hold this, oh, there we go. Let's hold this up in front of the camera so we can see that I can see you through there because this material, glass, is transparent. That means that the light can travel straight through it and I can see you clearly through it. But what do you think it's going to do in front of the infrared camera?
So if light can travel through it and we can see you, I think that maybe when we're looking at you through infrared camera, we will still be able to see you because the light will be able to travel through it.
Let's find out. Let's bring it up. Have a look. So if I give you a little wave here behind the camera, you can see me on the regular camera. Can you see me on the infrared camera?
No, can't see you on the infrared camera.
So the glass here is blocking the infrared light, even though it's letting the visible light pass through. So different materials can interact with different types of light in different ways. Isn't that interesting?
That's amazing.
I'm just going to take this out of the way. We don't need that now.
Thank you. So we are coming almost to the end of our show. So let's just do a little recap to talk about what we've seen and what we've heard about today. So we have talked about what we think invisibility might mean and how that invisibility might be helpful for certain objects. We've also talked about some of the invisible things that you guys have come up with. So you came up with some fantastic ideas, like sound and air and the sky. And hopefully you've had some really interesting, rich discussions with that in your rooms. We've also thought about how animals use invisibility to help them camouflage in their environment, to help them either catch their food or to stay safe away from their food.
But we did say that humans can't camouflage in quite the same way as animals, though, can they? So we can't hide in the same way.
I mean, you look a little bit different, Daniel. I think you're doing a pretty good job at hiding, and I don't fully know why.
Am I hiding? I feel like I'm just here.
Well, so I can't see. You seem to have lost your head and your arms.
Oh, that is quite a mystery, isn't it? I wonder how I did that. And that maybe is something you can think about after this show and try and have a conversation about how I have managed to go invisible. But we are coming very close to the end of the show now. So before we leave, we would just like to say thank you so much to everyone for joining us here today. It's a pleasure to be able to bring this live stream to you. And thank you also to Bex for assisting us with our experiments. Thank you to Ian and Roger for all the technical equipment, and the whole team at the Science Oxford Centre here have been really helpful in making this possible. And thank you again to you. Now, before we leave, we have got one big question for you to finish the show with. What if all materials were transparent?
A little bit like, oh, interesting.
So have a think about that. Share your answers in the live chat and we'll have a look at them after the show. And we hope that you join us again for another live stream. Thank you very much. Bye-bye.
Bye.